Okay, class, we're about to start lesson 3.3, which is on page 233, and the title of it is Buying Stuff Without Money. Learning objectives: to compute payments and charges associated with installment loans, to identify the true cost of a loan by computing APR. And number 3, evaluate the cost of buying items on credit. All right, so we're going to go down here to the bottom. And it says fixed installment loans. A fixed installment loan is a loan that is repaid in equal payments. Sometimes the buyer will pay part of the cost at the time of the purchase. This is known as a down payment. Here are some other key terms used to describe installment loans. Okay, we have the amount financed is the amount a borrower will pay interest on. So the amount financed will be the price of the item minus the down payment. The total installment price is the total amount of money the buyer will ultimately pay. Total installment price is the sum of all payments plus the down payment. And then the finance charge is the interest charge for borrowing the amount financed. Finance charge is total installment price minus the price of the item. Okay, so now we're going to move on to page 234. Now, all those definitions that I just gave you, we are going to go over those. So I'm hoping that when we do go over those, that you will get a better understanding of the definitions. Okay, now it says, now let's take a look at the problem posed in this lesson's opening paragraph. The pertinent information is this. The cost of the car is $12,260. The down payment is $3,000. The monthly payment is $231.50. And the term of the loan is 48 months. So number one, what was the amount financed? Refer to the definitions on the previous page if you need to. Okay, now remember, the amount, I'm going to put AF, that's for amount finance. The amount finance is the cost of the item minus, and I'm going to put DP, that stands for the down payment. The cost minus the down payment. So the amount financed, the cost is $12,260 minus the down payment is $3,000. So 12,260 minus $3,000 is $9,260. So that is the amount that you would need to borrow. All right, and that would take care of, we look here, that would take care of the amount finance portion. So again, remember, if you have any questions, please ask the questions. I will gladly take any questions. Now we go here to number 2. What's the total amount of all monthly payments? Now they told us that the monthly payment is $231.50, and they tell us the term of the loan is 48 months. So we'll multiply that by 48. $231.50 times 48 would give us $11,112. Okay, now it says, what's the total installment price? Now, the total installment price, I'm going to abbreviate that with TIP to stand for the total installment price. So the total installment price is the total monthly payment. I abbreviate with TMP, total monthly payment, plus the down payment. So the total monthly payment was the $11,112 that we got back in problem number 2. And then we have to add the down payment, which we know up here the down payment was $3,000. So now we will add those two together, and our total installment price will be $14,112. And that would take care of number 2 from the previous page, the total installment price. Now we go here to number 4. It says find the finance charge, then describe what the amount really represents. So the finance charge, I abbreviate as FC, is equal to the total installment price minus the cost. So the finance charge, the total installment price was $14,112 minus the cost. If we look back up here, the cost was $12,260. So now when we subtract these values, your finance charge would be $1,852. Now they ask us to describe what that amount really represents, what this amount really represents. This is the total interest paid over the life of the loan. That's what that represents. Now, and that, of course, is the last portion that we studied from the previous page. Okay, so now we go on to the next page. It says, in some cases, it's a good idea to be able to calculate a monthly payment before making a purchase. Not only can this help you to decide whether or not you can afford an item, it gives you a way to make sure you're not getting cheated when you're quoted a monthly payment. So how can you find the monthly payment for a loan? Using a formula, of course. Although to be fair, there are many loan calculators online. Now, this is the formula for the monthly payment. And of course, we know M stands for the monthly payment, the P is the principal, the R is the annual percentage rate, and N is the total number of payments. So now I would tell you this. With a formula like this, even if you have a calculator, this will be a lot of typing in your calculator. That is why Desmos turns out to be the better calculator, because once you type it in once, all you have to do is just go back and change numbers. You don't have to keep retyping it in. So let's go down here. It says, have you noticed that car makers never have sales? There are always events. Weird. Anyhow, for the Ford 2015 holiday event, they offered a 2015 Taurus with a special APR of 2.9% for 60 months. If one particular vehicle has a selling price of $27,295 and a buyer trades in an older car for a down payment of $4,500, calculate the monthly payment for this loan. Now, first of all, we have to take a look at a couple items here. One item we need to look at is this here, the principal. Now we know the principal is supposed to be your starting value, or whatever the value is you first borrowed or the value you first saved. So for this principal here, we would take the cost minus the down payment, because that would end up being your principal. So your principal, the cost was $27,295, and then the down payment was $4,500. Now, when you subtract these, that'll give you $22,795. So this will be your principal. $22,795. Okay, next, our annual percentage rate is given to us at 2.9%. We'll rewrite that as a decimal as 0.029. And then the N is the number of payments, which here is 60, because it's 60 months, so it's 60 payments. So now we have everything we need here. We have the principal, we have the rate, and we have the total number of payments. Now we could put this in the formula. Now I want you to pay close attention to this. I have M is equal to P times R over 12 divided by 1 minus 1 plus R over 12 to the negative M power. Okay, that's the formula. Now we're going to do some substitution. The principal, which is this $22,795, times the rate, which is 0.029 over 12, all divided by 1 minus 1 plus 0.029 over 12 to the negative 60th power. Okay, now we have all of this, and this is going to give us what our monthly payment is. Now we're going to do this in Desmos. Okay, so now in Desmos, we would type in, let me grab my keyboard. We would type in the $22,795. Now, what I would suggest, is this is going to be a fraction, I would hit the division key and then go back up to the top, because that'll make it a lot easier. So now we have 22,795 times, then we will have 0.029 divided by 12. Now that took care of the numerator. Now we go down here to the denominator. We have 1 minus the parenthesis, 1 plus 0.029 divided by 12, and then press the right arrow and put your parenthesis. Now we have to take this to the negative 60th power. And here we have our monthly payment. Now remember, when we're dealing with our money, typically we don't go past 2 decimal places, typically. So we will go to 2 decimal places here. It'll be $408.58. So that will be your monthly payment. Any questions? Now, as a strategy, like I was telling you all how to make this a little easier as far as typing in values, I would not get rid of this until I'm totally done with what I'm doing, because you may need to type in another monthly payment problem, and all you have to do is just change some of the values instead of redoing the whole problem. Okay, number 6. If the loan was based on simple interest, the future value would be $22,795 times 1 plus 0.029 times 5. Calculate this amount, then divide by 60 to find the monthly payment. What do you think accounts for the fact that the simple interest makes it higher? Okay, so first we had $22,795 times 1 plus 0.029 times 5. Okay, now when we multiply all of this out, this will give us $26,100.28. So now we would take this value here and divide it by 60, like the direction told us to. And that would give us $435 exactly. Okay, now they ask us how come we think that simple interest is higher. And the reason being is, remember, one of the characteristics of simple interest is no matter how much you have in there, no matter how much the amount of time goes by, you still get the same amount of interest. So with a typical loan, when you start paying it off when it's not simple interest, when you pay it off the next month, the interest will get lower. Then the next month, the interest will get even lower. But if it's a simple interest loan, your interest do not go down as you pay it off. So we could say simple interest charges the same amount of interest until the loan is retired. But the monthly payment scenario from problem 5 assumes interest decreases with each payment. So that is the difference between the two. All right. Now, we ease on down here to the bottom. So we have annual percentage rate. Many lenders add upfront fees to a loan and then spread them over the life of the loan. This has the effect of making the actual interest rate that a borrower pays higher than the quoted rate. Because this can get confusing, lenders are required by law to disclose an annual percentage rate, or APR, that reflects the true interest charge. This allows consumers to compare loans with different terms. The mathematical procedures for computing APR are extremely complicated, so tables have been compiled to help you to estimate APR for a loan. There is also a wide variety of APR calculators available online. A partial APR table is shown in the following table. Now we see this table at the bottom. We're going to end up utilizing this table on the next page. Now at the top of page 237, you notice we have another tan box, and you know we like to pay attention to our tan boxes. It says find the finance charge per $100 borrowed using the formula. Finance charge divided by amount financed times $100. Step 2, find the row in the table marked with the number of payments and move to the right until you find the amount closest to the number from step 1. Step 3, the APR to the nearest half percent is at the top of the corresponding column. Okay, so number 7. It says find the finance charge per $100 for the loan described in questions 1 through 4. Step 1 in computing APR. So we want the finance charge divided by the amount financed. And we'll multiply that by $100. So we found the amount financed back on page 234, problem number 4. The finance charge was $18.52. And the amount financed was on the same page, but it was problem number 1, that $92.60. So now, when we divide and we multiply this by 100, and that would give us $20. Now I'll put that over here in the calculator. So you can see it. So we had 1852 divided by 9260. Put our right arrow here, times 100, and it gave us 20. So it's $20. So now it says, look at the row in the table corresponding to 48 months and find the two entries that are closest to your answer from question 7. Then find the APR corresponding to each and use the result to estimate the APR for the loan. Steps 2 and 3 in computing APR. Describe how you got your estimate. Okay, first of all, I can't really flip back and forth, but I will do this. They said go where it's 48 months, and then we'll go to the two values that's closest to 20. It'll be these two values here. And then if you go up to the percentages, you add 9% and 9.5%. Now, here's the thing. We're trying to get it to be 1%. Not the actual number one, but we don't want two different percentages. So what we would do with the percentages that's listed up here, we would add those percentages together. We don't have to put the percent sign here. Well, I'll put it. We'll add these percentages together and divide by 2. So it'll be 18.5% divided by 2, which is 9.25%. So we will use the 9.25% for our percentage. So we go back here to this page. So we would say that $20 is halfway between $19.45 and $20.59. So halfway between 9% and 9.5% is 9.25%, which is what we calculated. Okay, one way to save money on a fixed installment loan is to pay it off early. This would allow a buyer to avoid paying the entire finance charge. The amount of the finance charge that is saved when a loan is paid off early is called unearned interest. One way to calculate unearned interest for a loan uses the APR table we've already been introduced to. This is called the actuarial method. Okay. All right, now we move on to the next page. They give us the actuarial method. We have U is equal to KRH divided by 100 plus H. U is unearned interest. K is the number of payments remaining, excluding the current one. R is the monthly payment. H is the finance charge per $100 borrowed for a loan with the same APR and K monthly payments. All right. So they give us this reminder of what we had when we started this lesson off. And we look here at number 9. It says, when making your 36th payment, how many payments would remain? Okay, well, there were 48 payments. You're going to make your 36th payment, so you would take 48 minus 36. It's 12 payments that remain. Number 10, if you decide to pay this loan off at the time of the 36th payment, how much money would you save? You'll need to do some work to find the value of H. Use the 12 payments row of the APR table. Okay. So first of all, we have U is equal to KRH all over 100 plus H. So the first thing, let's list what we have here. We know that K would be 12, because we got that here, that it'd be 12 payments remaining. R is equal to the monthly payment. The monthly payment is $231.50. And then finally, H, well, first of all, U we don't know. And then H, right now, we don't know. So we need to find H in order for us to find U. So this is what we would need to do in order to get H. So we will have H is equal to, now what we would need to do is go back to this table, and we will go up to the 12 months, and then we will go over here to the 9% and 9.5%, because remember, the payments were between these two values. So we would take this $4.94 and $5.22 and divide them by 2. Now, when we do this here, that would give us $5.08. That should be your H value, which is the finance charge for every $100. Okay, now we have H, which is $5.08. Now we can solve. U is equal to KRH all over 100 plus H. So K is 12. R is 231.50. And then H is $5.08. All divided by 100 plus 508. So now we can put this in our calculator. We have our 12. I'll just do the division and come back up here to the numerator. And then we would do times $231.50 times the 5.08. That'll take care of, oh, I put 5.05. That'll take care of our numerator. Our denominator would be 100 plus 5.08. And then this would give us U. The unearned interest would be $134.30. So this is how much interest you will end up saving by paying it on the 36th payment. Now we flip this over to the next page. It says here, number 11. In this situation, you would surely want to know how much it would cost to pay off the loan. The first step would be to find the total cost of all the remaining payments after the 36. So do that. Okay, the monthly payments is $231.50, and it'll be 12 months remaining, which will cost $2,778. Now, for number 12, and one other thing, just to let you know, this is how much would be left. But look here at number 12. It says your answer to question 11 is what the payoff would be if you weren't getting credit for unearned interest, but you are. So subtracting the unearned interest you found will give you a payoff amount. So we would take this amount here and subtract off the unearned interest that we got back in problem 10, which is $134.30. When you subtract this, it'll be $2,643.70. That's how much you would have to pay. Like you would make your 36th payment, and then if you pay this, then you're done. Now, number 13, discuss the pros and cons of paying off that particular loan early. If you were in this situation, do you think it would have been worthwhile for you to pay it off early? Now, here's the thing with that. I'm going to do one pro and one con. The pro is the loan is finished and you save $134.30. The con is you have to come up with $2,643.70 all at once. That's a lot of money to have to come up with all at once versus the $231.50 per month. Okay, now they asked the question: if you were in that situation, do you think it would have been worthwhile for you to pay it off? I think so, because I would rather pay it off than give away $134.30. Now remember, they said if you were in that situation, meaning you had the money, would you do it? And I would. Saved $134.30. All right, now we move on to the next page. Now we have the unpaid balance method. Now the unpaid balance method, it says one way that banks calculate finance charges on a credit card is the unpaid balance method. In this case, interest is charged only on the balance left over from the previous month. Suppose that you had an unpaid balance of $356.75 at the beginning of August and made purchases of $436.50. A payment of $200 was made during the month. The interest on the unpaid balance is 1.8% per month. Our goal would be to find the finance charge and the balance on September 1st. The billing cycle for credit cards and loans can begin and end on any day of the month. However, for the examples given in this lesson, we'll assume the cycle ends on the last day of the month. Now, number one, it says find the amount of interest that will be charged on the unpaid balance. Show your work. Okay, the unpaid balance was $356.75. And they tell us here that you would pay, where is that at? I thought I just saw it. Oh, here it is. 1.8%. So it'd be 0.018. Now, when you multiply that, it'll be interest of $6.42. Now, number two, use your answer from question one and the information about payments and purchases to find the new balance on the card. Show all work again. Okay, so it'll be $356.75 plus this charge here, the unpaid balance, $6.42. Plus, remember, you were told here you made purchases. So you know that increases the credit card. And then it says here you had a payment of $200. So you'll subtract off $200. Now, after you do all of that, you end up with $599.67 on the credit card. Okay, now we move on to the next page. Now we have what is called the average daily balance method. Because a company that issues credit card doesn't make as much money when users pay off the balance every month, they sometimes charge an annual fee for use of the card. Another way for them to make money from all users is to use the average daily balance method for computing the finance charge. In this method, the balance for each day of the month is used to compute an average daily balance. and interest is computed on that average. So in effect, consumers start paying interest on the day they make a purchase. Ouch. Calculations using the average daily balance method can be done in a series of steps, as illustrated by the next set of questions. The credit card statement shown here displays more detail on the account we study in questions 1 and 2. Okay, the goal is to find the average daily balance, the finance charge for the month, and the new balance on September 1st. The interest rate is 1.8% per month on the average daily balance. Okay, so it says find the balance on each day that a transaction occurred. Write the new balance next to each day listed below in the first blank. Ignore the second blank for now. Okay, we started the month off at $356.75. Okay, now on August 7th, there was a purchase made of $59.95. So you would add these two together, and that'll give you $416.70. Now, August 12th, there was another purchase. So you would add this $223.75 here, and that will give you $640.45. Now you had a $200 payment, so you'll subtract 200, so that'll be $440.45. Then last but not least, you made another purchase of $152.80, so you will add that, and that'll be $593.25. Now, it says find how many days was the balance $356.75. Okay, if you go from the 1st to the 7th, you would not count the 7th. So it'll be basically from the 1st to the 6th. So then that'll be 6 days. Using the same idea, fill in the second blank next to each balance above with the number of days that the balance was at that amount. Make sure the total number of days adds up to 31 days, because that's the number of days in August. So from August 7th to the 12th, we know we will stop at the 11th. So basically we're going from the 7th to the 11th, which would be 5 days. And then the 12th to the 17th, which would be 6 days. Then the 18th to the 23rd would be another 6 days. And then remember, the month ends on the 31st day. So when we get here to the 24th, we would go from the 24th to the 31st, and we will count the 31st as well. So that would be 8 days. So when you add all these together, it will give you 31 days. So that took care of that problem. Now we're going to go over here to the next page. Now it says copy the first 2 columns in the table below from your answers on the previous page. Then multiply to fill in the last column. Then add your results. So it's 356.75, 416.70, 640.45, 440.45, and then 593.25. That's what we came up with over here on the previous page, and then the number of days. So we will have 65668. Now, what we have to do next is this here. We're going to have to take the balance and multiply it by the number of days. And then that will give us the balance times number of days. So we can take our Desmos calculator. So we will have, let's see, 356.75 times 6. Let me minimize this a little bit. Then we have 416.70 times 5. Then 640.45 times 6. 440.45 times 6. And then finally 593.25 times 8. All right, so we got 6, we got 2,140.50. Then we had 2,083.50. And $3,842.70. And $2,642.70. Then 4,746. Now, when we add all of these up, it'll give us $15,455.40. All right. Now, for number 6, it says divide your sum from question 5 by the number of days in August. So we'll take this 15,455.40 divided by 31, because we know it's 31 days in August. This gives you the average daily balance for the account. When you divide this out, it'll give you $498.56. Now, number 7, it says recall that interest on this card is 1.8% per month. How much interest will be due on the average daily balance? So we'll take the 498.56 and multiply it by 0.018. And that'll give us $8.97. Now, step 6. It says find the new ending balance by adding the finance charge to the last balance. So we have $593.25. Because remember, this was the last balance here. So $593.25 plus the $8.97. So your new balance would be $602.22. Now, look down here at the bottom of the next page. It says, suppose you have a $2,300 balance on a credit card with an interest rate of 1.25% per month. And the minimum payment for any month is the amount of interest plus 2% of the principal balance, or $5, whichever is higher. If you don't make any more purchases on that card and make the minimum payment for 6 months, how much will you pay down the balance? Let's find out. By the way, the interest and minimum payment percentages in this problem reflect industry averages in 2015. Okay, number 9, this certainly sounds like we'll need to compute some interest. After all, we were told that the interest is 1.25% per month, but sometimes problems contain extraneous information. Read the problem carefully and explain why we don't need to worry about the amount of interest in calculating how much the balance decreases. The reason being is we'll pay all the interest off each month by making the minimum payment. And that's evident because with the minimum payment, they tell us that for any month is the amount of interest plus 2% of the principal. So the interest is only 1.25%, but you're going to be paying 2%. So you're going to take that out and then some. Okay, now, so it will have no effect. The balance will decrease by 2% of the principal. All right. Now we're going to move on. It says, in fact, what really matters is that the balance is going to decrease by 2% each month. Use this fact to find the new balance after 1 month. Okay, listen. Let's say balance was $2,300, which was stated in problem number 9. It's telling us that it's going to go down by 2%. So if it didn't go down at all, we know that we would keep the whole 100% of 2,300. But since it's going down by 2%, that means that we're only going to have 98% left. So we would take 2,300 times 0.98, which would give us $2,254. That's how much our balance would be after we make our minimum payment. Now, number 11, it says repeat these calculations from question 10 5 more times to find how much the balance would have decreased after 6 months. Someone had a question? Oh.
No, I didn't.
Okay. All right. So this is the first month. So we'll go to 2 months, 3 months, 4 months, 5 months, and then 6 months. Now, we don't have to keep writing out this formula. What we could do, since we have access to Desmos, what we could do is type out the initial equation, the 2,300 times 0.98, and we could put a y equals in front of it. And remember how we go to this wheel here? Click on the wheel, do a table, and then we could just see it here. Okay, 1 month, these would be your months. 1 month, it would be 22. Oh, wait a minute. You need to. Oh, you know what? I'm sorry. I did one thing incorrect here. I was supposed to take this to the x power. Let me just redo it. Okay, on your paper, we know this would be to the first power because it'll be to the first month. But the actual equation we know is y equals ab to the x, and then it just so happened that it'd be the first to the first power because it's the first month. But since it's the second month, this x would be a 2 and so on. So the formula we would type in is y equals 2,300 times the parentheses 0.98, and then we would take that to the x power. And then we will go here to the wheel, hit the table, and then if you notice here, when we put in the first month is 2,254. The second month will be $2,208.92. Now we come down here, we can type in 3. The third month would be $21,64.74. Fourth month will be $21,21.45. And the fifth month be $2,079.02. And then finally the sixth month It'll be $2,037.44. Okay, now we come here to problem number 12. It says, just make a guess. How long do you think it would take to pay off the full balance of at this rate? Discuss, then ask your instructor to give their thoughts on this question. Okay, listen. We have y equals ab to the x power. So we could take y is equal to, we have our 2300, 0.98 to the x power. Now what we want to do is basically get this down to either, there's a couple things we want to get this down to, either to 0 or, because of these directions, $5 or less. Because remember, it tells us that you will have to pay the interest plus 2% of the balance or $5, whichever is higher. So if it's $5 or less, then that will pay it off. So now, let me see here if this came up. It didn't. All right. So what we could do is this here. If, let me type this out. If we did y is equal to 2300, then parenthesis 0.98, close the parenthesis, then take it to the x power. Now, you have to do a lot of scrolling here to finally see this line. Okay, now you want to get down here as close to 0 as possible, well, as close to $5 or less as possible. So you see here at about, let me see, 304 is 494.48. So we could toy around with this. We could type in 304, 303. And if you notice here, this is over $5. So it'll be 304. So we could say about 304 months to get to $5 or less and pay it off. Again, it's about 304 months, and that's to get to $5 or less and pay it off. Now, this was a nice lengthy lesson, but now we're going to move on to 3-4, which starts on page 251. Now it says investing in yourself. Now this is where we're actually going to start doing some student loan type problems. And if we run out of time, I am going to finish this lesson up, even if we run out of time, and I will tell you in the email where you would need to go since you were in class at the time. But I think we might make it. Okay, lesson 3-4 on page 251. It's called Investing in Yourself. Our learning objectives is to understand different student loan options, to compute interest and monthly payments on a student loan, to evaluate the effects of capitalizing interest, analyze various aspects of a mortgage, compare two mortgages of different lengths, and to prepare an amortization schedule. All right. Let's go here to page 252. It says interest on student loans is simple interest. The interest accrues only on the principal balance, not on previously accrued interest. So while the student is still in school, the amount of interest that accrues each month remains constant. The interest is calculated using a simplified daily interest formula. which we can develop using things we know about simple interest. Okay, if the principal balance of a loan is $6,500 and the interest rate is 6.8% annually, how much simple interest will accrue in 1 year? So we know interest is equal to principal times rate times time. So interest is equal to the principal is 6,500. The rate is 6.8%, which is 0.068, and the time is 1 year. So the interest is equal to $442. Now it says, why does it make sense to use 365.25 days in a year for financial calculations? Because every 4 years we have a leap year, which adds an extra day. So 365.25 accounts for the extra day. Okay, number 3. Using questions 1 and 2, find the daily amount of interest that accrues on that $6,500 loan. Make sure you explain how you got your answer. So you would take the 442 and divide it by 365.25. And this will give you about $1.21 per day. $1.21 per day. Now, number 4, how much interest accrues in a month? Be careful. Now, remember, the reason why they're telling us to be careful is because there are actually 4 different type of months you can encounter. You can encounter a 28-day month, a 29-day month, a 30-month, or a 31-day month. So you'll all multiply these by the $1.21. Now when you multiply these, this will be $33.88, $35.09, $36.30, and finally $37.51. Now at the bottom here, they basically have what we went over, the simplified daily interest formula, which is the daily interest amount, principal balance, times the interest rate all over 365.25. And the monthly interest amount is the daily interest amount times days in a month. All right. So now we move on. It says here, for that $6,500 student loan we've been working with, if you start school in August, graduate in May, 3 years and 9 months later, and payments begin 6 months after graduation, how much time will pass while interest is accruing? Okay, so here it tells you 3 years, 9 months. So I'm going to write this up top. So it'll be 3 years, 9 months. But remember, they give you 6 more months before you start payments. So if I add the 6 additional months, that would give me 3 years and 15 months. Now we know 12 months is equal to a year. So if we subtract 12 months here and add 1 year here, that would give us 4 years and 3 months. So it'd be 4 years, 3 months. Now, number 6, write out the months that come after the last full year ends. Then the number of days in each of those months. So what they're saying is this here. We know from August to August is a year. So since we're at 4 years and 3 months, the fourth year will end in August. So we want the 3 months after August, which would be September, October, and November. And we know September has 30 days, October has 31 days, and November has 30 days. All right. Number 7. It says find the amount of interest that accrues in the number of full years from your answer to question 5. So we know in the full year is $442, but it's 4 years, and that'll give us $1,768. Okay, number 8. It says write the amount of interest for each of the months listed in question 6. Your answer to question 4 will come in very handy. So if we look here at September, we know that it's 30 days. So we'll take 30 times the $1.21 that we found out earlier. October, 31 days times the $1.21. And November will be 30 days times the $1.21. Now we multiply this out, this would be $36.30. This would be $37.51 and $36.30. Now they ask us, how much total interest accrues before payments begin? So we'll take the answer from number 7 and we'll add the values from number 8. 36.30, 37.51, and then 36.30. When we add all of that up, it'll be $1,878.11. Yeah, I know that's a lot of work, but I know that you all can handle it. All right. We move on to the next page. It says when interest is covered by the government while the borrower is still in school, a student loan is called subsidized. If interest is added to the principal while the borrower is in school, the loan is called unsubsidized. For the loan in questions 1 through 9, the student would have saved $1,878.11 by acquiring a subsidized loan. When monthly payments begin on a student loan, they're based on the principal balance at that point in time. These payments can be computed using the following formula, which should look familiar. It's exactly the payment formula we studied in lesson 3.3. We just thought we'd be nice and recopy it rather than making you page back. You should, also since most student loans have a 10-year term, we took the liberty of adapting the formula to that situation. Again, if you look here, the monthly payments of a student loan, we know P is for principal, R is the annual interest rate, and then this 120 is where N would be, and that's the number of payments. Okay, so now, number 10. It says for the loan in questions 1 through 9, what is the principal amount at the time payments begin? So, $6,500 is what you initially had, but remember, $1,878.11 is added to this. So when you start making payments, this would be your new principal. It's $8,378.11. Now number 11, it says find the monthly payment on the loan. So first of all, we have our principal, which is $8,378.11. We have our rate, which is 6.8%. So it'd be 0.068. And then our number of months we know would be 120, or number of payments. So we have M is equal to P times R over 12 divided by 1 minus 1 plus R over 12 to the negative M power. So now we substitute. We get $8,378.11 times 0.068 all over 12 divided by 1 minus 1 plus 0.068 over 12 to the negative 120 power. Now, remember how I told you all what's nice about Desmos? If we go back up here, remember this was the monthly formula. All we have to do here is just change some of these numbers. We don't have to retype in the whole formula. So we would put in the $8,378.11. Then the numerator, we'll put in our 68. The denominator is 68. Then that'll be a negative 120. So our monthly payment will be $96.42. Now, says we've seen that with the student loan, you have the option of not making any payments until after graduation. When interest on an unsubsidized student loan is not paid during college, we say that the interest is capitalized. When interest is capitalized, it adds to the principal balance, which of course results in larger payments. When interest is not capitalized, payments have to be made during college, but only covering the amount of interest. This keeps the principal balance the same until full monthly payments start, which makes those payments smaller. All right. Move on to the next page. All right, so it says for the student loan, we've been working with the payment while still in school would simply be the amount of interest that's accruing, which you already calculated. For reference, in the space below, write the amount you pay in an average 30-day month, as well as the total amount of interest you pay before regular monthly payments begin. So 30 days, it'll be $36.30. We already calculated that before. And the total interest, which we calculated again before payments, is $1,878.11. Okay, number 12. With interest not capitalized, the principal balance of the loan would still be $6,500 when full payments start. Find what those payments will be. Okay, so basically, we're taking this same formula, but instead of it being $8,000 as the principal, the $8,378.11, we're going to instead just do the $6,500, as if the student had paid the interest while they were in college. So all we have to do here on Desmos, we only have to change one thing, and that's just the principal. So it's supposed to be 6,500. So we would type in 6,500. So our payment would be $74.80. Now it says you'd make 120 payments on the loan. Use your answer from question 12 to find the total amount of money that you pay on the original $6,500 loan. So it'd be $74.80 multiplied by 120 months plus the $1,878.11 that you already paid So you would pay a total of $10,854.11. That's how much money you would pay. Now, the key question when studying whether or not to capitalize the interest. If interest is capitalized after paying nothing while in school, you'll end up making 120 payments of the amount you found in question 11. So how much money would you save by paying for the interest while still in school? Okay, for number 11, we had $96.42 a month payments. And you'll multiply that by 120, and that will give you $11,570.40. Okay, that's how much you would end up paying. Now remember that $1,878.11 is already encompassed in this payment. So you would take this $11,570.40 and you will subtract the $10,854.11. When you subtract these two values, that will give you a savings of $716.29. So basically, you would save about $70 per year by paying while you go to school. Now, whether it's worth it or not is up to the individual. Yeah, it's really up to the individual. Okay, now we go over here to the next page. We're going to talk about mortgages for a little bit. A mortgage is a long-term loan where the lender has the right to seize the property purchased if the payments are not made. Homes are the most common items bought using mortgages. The most common mortgage term is 30 years, but they are widely available in terms from 15 to as many as 50 years. There are several types of mortgages. With a fixed rate mortgage, the rate of interest remains the same for the entire term of the loan. The payments, usually monthly, stay the same. With an adjustable rate mortgage, the rate of interest may fluctuate during the period of the loan. If you opt for an adjustable rate mortgage, it will start out with a lower interest rate than a fixed rate loan of the same length. Discuss the pros and cons of fixed and adjustable rate. So I'm going to put one pro and one con for each. So we have the fixed mortgage and then the adjustable rate mortgage. Okay, the fixed mortgage pro, you know how much you owe each month. With no change. The con, interest rates interest could go lower, but you will not enjoy it because yours is fixed. Now, unless you refinance, but that's a whole nother thing. Okay, adjustable rate mortgage, pro, lower payments initially. The con, rates go up and your payment goes up. Okay, now it says discuss the pros and cons of buying a house compared to renting. All right. buying a house, renting. Okay, a pro, get privacy with a house. The con, you have to pay for everything. Renting, pro, do not pay for everything. The con, no privacy. So those were somewhat of opinion questions. So, I mean, there may be some apartments out here where you may get some semblance of privacy. Okay, now, it says the Petty's family plans to buy a house for $224,900 and has been offered a 30-year mortgage with a rate of 5.5% if they make a 20% down payment. Calculate the down payment and the amount they'll have to borrow. Okay. So the house is $224,900 and they're going to put a 20% down payment. So their down payment is going to be $44,980. That is the down payment. Now, to see how much they need to borrow, you need to subtract the down payment. And that will give us $179,920 that you have to borrow. Now, 18, the monthly payment on the loan will be $1,021.57. How much will the Pettys actually pay for their $224,900 home? So, you had 30 years and you know it's 12 payments per year. So that's 360 payments they would make. Now they're told their monthly payment is $1,021.57. They have to multiply by 360 payments. So let me put this in here. So I really didn't need all of this. Okay. All right. So we have $1,021.57 times 360. So this will give us $367,765.20. Now remember, these are the monthly payments, but to get what they totally paid, you have to take this value here and add the down payment as well. So when you add all of that together, that gives us $412,745.20. Right now on the back here, page 258, it says in the space below, recopy the formula that we use for computing monthly payments on a student loan with a term of 10 years. Then describe the significance of each part of the formula requested below. Okay, first of all, this is the principal. And then this is the annual, the R is the annual interest rate. And then this 12 is number of payments per year. All right, so the formula was M is equal to P times R over 12 divided by 1 minus 1 plus R over 12. And then we add to the negative 120. That was for 10 years. Where do you think the 120 comes from in the formula? So we will put T, and this would be equal to years. We're going to add in another variable. So basically, this would be number of years multiplied by number of payments per year. Number 3, using your answers to questions 1 and 2, adapt the student loan monthly payment formula into a general formula. Okay, so basically they want us to rewrite this using this as a general formula. So it'll be M is equal to P times R over N divided by 1 minus 1 plus R over N to the negative NT power. Now we know N represents the number of payments, T represents the number of years, R is the annual interest rate, and P is the principal. So that's basically what they wanted us to do here. So now we're going to end up using this formula. All right, so it says earlier we studied a loan obtained by the Petty's family with these terms. Purchase price $224,900, 20% down payment, 30-year mortgage with a rate of 5.5%. The monthly payment was $1,021.57. How much higher would the monthly payment be if they put only 10% down? Okay, so we had 224,900. We have to multiply that by 0.10. So it'd be $22,490 would be the down payment. So the new principal, and I just put it as new principal. You could just put it principal. The new principal would be the 224,900 minus 22,490, which would give us $202,410. So we will put that in a formula. The M is equal to the principal times rate over N, 1 minus 1 plus R over N to the negative NT. So the principal is 202,410. The rate, we're told the rate is 5.8%, so it'd be 0.058 all over 12 divided by 1 minus 1 plus 0.058 over 12 to the negative. Now N we know is 12, and then they tell us the number of years. Well, they don't actually tell us the number of years, but we're going to assume that it's 30 years. Yeah, it does right here. It's a 30-year mortgage. So we could put this right here in Desmos. So we'll put the 202,000, what's that, 410. The numerator would be 0.058. Down here, be the same thing. And then here, we'll take 12 times, oh, wait a minute. We have to put this in a parenthesis with the 12 times 30. Or you could have just put 360. So the monthly payment would be $1,187.65. So now they want us to find out how much higher would it be with just this 10%. So what we could do, they tell us that the monthly payment was, well, first our new monthly payment is $1,187.65, and minus the previous monthly payment, which is $1,021.57, and that's from the 20% down payment. So it would be, I'm going to write this down here. It would be $166.08 higher. Okay, number 5. It says, how much more would they end up paying over the life of the loan? So, what you would need to do is take the monthly payment, multiply by 360. That'll give us $450,044. And then we would have to add on the down payment. So we have $450,044 plus the down payment of the $22,490. Let me put that in here. So they would have paid a total, let's see, 150,044 plus. They would pay a total of $472,534. That's how much they paid for the house. Now we had already figured out how much they would have paid for the house with the 20% down payment. So it'd be $412,745.20. So now we would subtract them. So we have 472,534 minus 412,745.20. So it'd be $59,788.80 more. Now, number 6, it says, now let's examine the term of the loan. If they chose a 15-year mortgage with 20% down at 5.5%, what would the monthly payment be? Okay. So they put 20% down. The 20% down is still going to be the same thing like we did before. When we did the 20% down, that ended up 20% down. That ended up leaving us with $179,920 we had to borrow. So now we have, this will be our principal. Our rate is 0.055. And then our N was 12 and our T is 15. So all we have to do now is just substitute. We could go right here. 179,920. Numerator. We go down here. And then it'd be 12 times 15. And that will have our monthly payment at $1,470.10. Now, number 7, how would their total cost compare to the other two options we studied? So we did $1,470.10 times 180. So let me put that in here. $70.10 times 180. And then we have to add our down payment. The down payment for that was, what was that? $44,980. So that would be $309,598. That's how much was paid. And then the other two, we know that, well, they said how does this compare? So we would do the first one, which was a 20% down, 30 years, was $412,745.20. minus is 309,598. And then we would take the next value, which is 472,534 minus the 309,598. So we'll subtract both of these. 412, 745.20 minus 309, 598. So that'll be $103,147.20. Then we would take this, 472,534. So that'll be 162,936. So that's how much you would end up saving. All right, now we go to the back here at the bottom, and we're actually almost done. It says in the next group of questions, we'll use these steps to compute the first 3 months of an amortization table for the Petty's loan principal, $179,920, rate 5.5%, and monthly payment $1,021.57. A template for the table is included in question 12. Fill in the information as you find it. Okay, so calculate the interest for the first month on the loan and put it into the interest column on the table. So the interest is equal to, we have 179,920, and we'll multiply by the 0.055, and we'll divide that by 12. And this will give us $824.63. Now the only thing divided by 12 is the 0.055, not this whole problem here. So it'd be 824.63, and they want us to add this to the table on the next page, and it's actually in the middle here. So the interest would be 824.63. And then we go here to number 9. Number 9, it says subtract the interest from the monthly payment, and this is how much is paid to the principal. So it'd be $1,021.57 minus the interest, which is $824.63, which will give us $196.94. So we'll put $196.94. And then we want the balance of the loan. So we would take, to get the balance of the loan, we would take the 179,920 and minus this value here, this 196.94. And then that would give us the new balance of the loan, which would be 471. Oh, wait a minute. I put it in too high. Hold on. Let me go back here. Is 179,920 minus 196.94. So it should be 179,723.06. All right, now this is the last page here, and we're almost done. So we go here to number 10. It says calculate the new balance of the loan by subtracting the payment on principal from the original principal, then put that in the last column, which we actually already did, but I'll write it out. 179,920 minus the 196.94, which gave us 179,723.09. Now it says repeat the previous steps for the next 2 months. Okay, so what we would do, we had interest is 179,723.06, then times 0.055 divided by 12, and that would give us 823.73. So this would be $823.73. And then we would take our $1,021.57 payment minus the interest. And that would give us $197.84. Then our new balance would be $179,525.22, which I'll put it here. So that would give us our new balance, $179,525.22. Now this was the second month. We have to do the third month now. So the interest would be $179,525.22 times 0.055 divided by 12. And that would give us $822.82. Then we would take our monthly payment, subtract our interest, which is $822.82, which would give us $197.84. No, actually $198.75. $198.75. And then finally, we will subtract that from the principal, the $179,525.22 minus $198.75. And that would give us $179,326.47. All right. Now, what does this table say about what the bulk of your payment goes to when you begin making payments on the mortgage? It goes to the interest initially. What about near the end term of the loan? It will go to the principal. As the loan nears the end. So that's basically it. And we are done with 3.3 and 3.4.